Hello viewers, a warm welcome to all of you in this important topic. Now, in digital communication, often we discussed some mathematical term, their Q, ERF, ERFC functions. Some of you inquired me about those terms. Those are very important mathematical terms and they are required to express in mathematically to simplify the expressions in digital communications. So let us start the discussion of today's topic. So today's topic is Q, ERF, ERFC function. So basically, Q function is used for computing the area under the tail of the probability distribution function, which is known as PDF of Gaussian distribution. There are different types of the distribution, but for simplicity, we consider the Gaussian distribution. Q functions are often encountered in the theoretical equation for bit error rate involving AWGN channel. What is an AWGN channel? AWGN channel is additive white Gaussian noise. Why this additive? Because noise are additive in nature. That's why the name is additive. And the characteristics is Gaussian. So there is term Gaussian is introduced. And why white? Because all noise components are present. That's why the name is white. That's why the total name is additive white Gaussian noise. Gaussian process is the underlying model for an additive white Gaussian noise channel. The probability density function of a Gaussian distribution is given by Px is equal to 1 by sigma root 2 pi e to the power minus x minus mu square by 2 sigma square. The corresponding figure is as shown, where mu is the mean and sigma square is the variance. And what is x? X is basically one random variable. Why random variable? Because you are choosing this x randomly. There may be a different values or random values for this x. That's why the name of the variable is random variable. Now, the area of the shaded region in the figure is given by probability or PR capital X is greater than equal to small x0 is equal to x0 to infinity px dx. If you put the value of the px, that means 1 by sigma root 2 pi e to the power minus x minus mu square by 2 sigma square. What will be the expression? The expression will be the x0 to infinity integration x0 to infinity 1 by sigma root 2 pi e to the power minus x minus mu square by 2 sigma square dx. Now, if you consider y is equal to x minus mu by sigma, then what happened? Then the probability is y greater than x0 minus mu by sigma is equal to x0 integration x0 minus mu by sigma to infinity 1 by root 2 pi e to the power minus y square by 2 dy. Now, Q function can be defined by capital QZ is equal to z integration z to infinity 1 by root 2 pi e to the power minus y square by 2 dy. So what happened? So probability y or PR y greater than x0 minus mu by sigma is equal to capital Q x0 minus mu by sigma, which is nothing but capital Q z. Now, the complementary error function represent the area under the two tails of the zero mean Gaussian probability density function of variance sigma square is equal to half. The error function gives the probability that the parameter lie outside that range. So, what is the complementary error function? The complementary error function is given by the notation erfc z is equal to 2 by root over pi z to infinity e to the power minus x square dx. Remember, in this case erfc z and z is basically one range from z to infinity. Hence the error function is given by erfz is equal to 1 minus erfcz. So what will be your erfz? erfz is equal to 2 by root over pi 0 to z e to the power minus x square dx. Hence, the relation between the q function and complementary error function is capital Qz is equal to half erfc z by root 2. If we have a normal variable, that means capital X belong to capital N mu sigma square, the probability that capital X is greater than small x is probability x greater than x is equal to capital Q x minus mu by sigma. If we want to know the probability that x is away from the mean by an amount a, then probability capital X is greater than mu plus a is equal to probability of x is less than mu minus a is equal to q of capital Q of a by sigma. If we want to know the probability that the x is away from the mean by an amount a, then probability mu minus a greater than capital X is greater than mu plus a is equal to 2q a by sigma. Now, the plot of the q function is as shown in the figure. Now let us discuss the application of the q function. Q function is widely used in digital communication, as I told you earlier in this lecture. And it is also used in signal and system, basically to simplify the expressions. Also, it is used in wireless communication. So what we have discussed today? We have discussed today the Q function, then error function. After that, we discussed complementary error function, and lastly we discussed application of the Q function. That's all for this segment. Stay safe, stay healthy, and stay tuned to Ganon. Thank you, viewers. Bye.